most part, solving simple inequalities is going to feel a lot like solving simple equations. We don't do much that is different. So, for example, 3n's plus 11 is greater than 6. Right? The same kind of things that we would do to solve an equation we'll do to solve this inequality. Identify the center of the inequality. So you're looking at the inequality symbol rather than the equal symbol. Okay? Identify what's the variable, m, what's happening to the variable, times 3, and then plus 11. How do I undo that stuff that's happening to the variable? I will subtract 11 and then divide by 3. Okay, so this is my plan. Put it into action. Subtract 11. Do the same to the opposite side to keep the relationship balanced. We've got 3m's plus 11 minus 11 cancels. Keep your symbol. It's greater than 6 minus 11, negative 5. Okay, next move, divide by 3. Divide by 3. Keep the balance by doing the same thing on both sides. We've got 3 divided by 3 cancels, and keep your symbol is greater than negative 1.6. Repeating. Okay, so very much like skill number 10, solving equations. All right, I'm going to ask for each problem that you add in, throwback to lesson number 1, a representation of this on a number line. So if you remember, we will choose numbers close to the key value that we care about, negative 1.6. So I'm going to put 0, negative 1, negative 2, negative 3, 1. And then you want to have a mark, either an open circle or a closed circle, at the edge of this. So in this case, we're not allowed to equal negative 1.6. So we want an open circle, in this case, between negative 1 and negative 2, a little bit closer to negative 2. All right, and then shade, what is m allowed to be? M is allowed to be bigger than that and not less than that. So I will shade in the direction larger. Okay, so that's how a simple inequality will look. Now, there is one special circumstance. When we multiply or divide both sides by a negative value, the relationship reverses. I'll show you what happens, what I mean by that as we work through this. All right, starts out the same. Where's the variable? Here. What's happening to the variable? Divide by negative 12, and then minus 7. How do I undo those steps? I will add 7 and then multiply by negative 12. Okay? Carry out the plan. Add 7. Those will cancel. K over negative 12 is less than or equal to 10. All right, next move, multiply by negative 12. 10 times negative 12, negative 120. Times negative 12 divided by negative 12 cancels out. K, negative 120. All right, this is what I mean when I say the relationship reverses. Because I'm multiplying both sides by a negative, this symbol needs to flip around. K is not less than or equal to 120. K is greater than or equal to 120. Okay? That's what I mean when I say flip the symbol around. All right? When do we do it? only if we are multiplying or dividing both sides by a negative value. We graph this, negative 120, negative 119, negative 121. K is allowed to equal this, so closed circle, and it's allowed to be bigger, so shade above. Why? Why does multiplying by a negative value end up or result in flipping an inequality symbol? I'm going to show you one example of why it works and let you know that in general, multiplying by negatives works this way. Okay? So let's say you start with the values 2 and 3, or negative 2 and negative 3. Okay? Start with these two values. Now, which one is bigger? Right? Remember, negative 2 is bigger than negative 3. It's better to lose $2 than to lose $3. Okay? So negative 2 is bigger than negative 3. Negative 3 is smaller than negative 2. All right? Now, if I take those numbers and I multiply them by 2, positive 2, I will end up with negative 6 and negative 4. Okay, still the purple is smaller than the red, just like when they start. If, on the other hand, I multiply by negative 2, so negative 2 times negative 2, negative 3 times negative 2, I'm going to get positive 4, positive 6. All right. When I flip over 0, all right, negative 2 times negative 2 is positive 4. Negative 3 times negative 2 is positive 6. Notice my red arrow is smaller than my purple arrow, or it might look blue on your screen. Right? Red is smaller than purple or blue. Okay? 4 is smaller than 6. So you can see right there with just one example, the inequality symbol needs to flip to make the statement true. Okay? And hopefully you can also visualize with this picture. When I'm multiplying by a negative, I'm flipping my number line across a 0, and that's what is resulting in the change in relationship. Okay? The same kind of way that quote unquote bigger negatives are actually lesser. Right? When I flip into negative territory. Same idea is going on here. Right? If we multiply by a negative, we flip over 0 and our relationships reverse. All right, hit pause. Try these on your own. See what you can do with them. And then unpause and double check against what I've done. All right, so you can test yourself.